and girls, we have been talking about so many different strategies with multiplication. Raise your hand if you can tell me the one that, out of these three that you see at the top of your page and up here, which one do you remember learning first? Probably in 4th grade. I think that, honestly, most of you started multiplying in general, 2nd, 3rd grade. But which of these do you remember learning first? Charlie?
I remember learning partial products.
I think, yes, that one applies so much to place value that I think that is usually the one that I hear most people do first. And then which one of these directly relates to partial products? It's a visual representation of partial products. Emerson?
Area models.
The area models. Those go together. So this partial products method and our area model representation are going to match up really, really well. Okay? Now the new way that we've started practicing, that's more of a shortcut, that completely we could explain using place value, but it's just a faster way to do it. Which one of these is that, Ella? You're going to in just a second. So what's the newest method that we've just learned? Standard algorithm. Awesome. So now she's exactly right. You're going to write 73 times 5 in the box on the top of your organizer. And we're going to work through these three representations. Okay? So partial product in the standard algorithm, you typically line up vertically. So we'll do that. So 73 times 5 twice, please. Now, I've given you 3 different colors, crayons to use, that are kind of highlighter colors that we're going to use to shade over, to match up the steps, okay, of these 3. Now, before I actually start working through the steps, we're going to do the first step on all 3 together, and then move through the 2nd step, 3rd step, however much we need to get to the final answer. The colors are going to match up. Where is the first step in partial product? Where is the first step in standard algorithm? And then where the first step is here. That's what the colors are going to be for. Okay? Now, who can raise your hand and tell me, based on the way that I drew this area model, which of the values in our original equation belongs right here to measure that length? Length times width, remember, is area. What goes right here? Addie? The 70. Exactly. So put a 70 here. And actually, since it's at the top, that also could be the same length as the bottom. Exactly. Okay, so I'm going to put that down here. Someone else, raise your hand and tell me this smaller part right here, because we want the entire length to represent one of our numbers in our equation, obviously. Okay, Sam, what would that be? Right here. That's the 3. Awesome. And then obviously we need to put the 3 at the bottom we talked about. And guys, everybody, what goes on the ends? 5. The 5, because it's the 1-digit number. So now this rectangle represents an area model of, it could be a room, a hallway, a small garden we talked about. It's the area that this rectangle takes up. Okay? Now the first color that I want you to use, after we write in pencil in a second, is going to be yellow. So everyone choose your yellow. And raise your hand. What is the first step in every single one of our strategies? They're all what, Ben? 3 times 5. Well, clearly, 3 times 5 is always 15. I'm going to move this up just a little bit because I just realized, I remembered with partial product, we need to have a little bit more space. So I'm going to move that up just a little, okay? Because in partial product, we stack our steps. So, with pencil, put down a 15 like this. Now, where does the 15 belong in our area model, actually? I'm going to go to that one next. Actually, probably going to structure it this way so that you remember that I think partial product we talked about really relates to the area model best. So we're going to kind of go that way. Okay, Truett, where would the 15 go? In the smaller area. Okay, good. So 15. And then how about in the standard algorithm? How does 15 factor in there? Brandon, how should I do it?
You do 15, you put the 5 down, and you put the 7.
Exactly. I regroup the 1. Okay? So now, with your yellow, we're going to lightly shade over that first step that we just did, which would be here, here, shading over. And then on the algorithm, I would shade it the same way, except I'm going to shade the 5 and the 1 up top to show that's where my 10, which is just represented with a 1 here, where it went. Okay? And then finally down here, I'm going to shade in the 15. You don't have to shade in the entire area model box. I know this 15 one's pretty small. Okay? Bless you. I'm going to shade over these numbers as well, because that is where the 3 times 5 step was in that step. Okay? In that model. Now, the second step in all 3 partial product, remember the steps are stacked and it's all about place value. This really is, these two digits are in the ones place. So this really is 5, and this really is worth 3. That's the value of them. So it's just 15. But technically in this problem, who can give me the value, the second step, as far as the actual value of the digits goes? What would that be, Emily? 5 times, okay? As far as the value, what is the 7 actually worth? So what is 5 times 70? 350. That is the way we show partial product, talking about the value of every digit. So 70 times 5, we write 350, okay? Now, over here in our, went down here again to the area model. 7 times 70, times 5 represents our larger section of our area model. So the 350 goes on the inside. So in the standard algorithm, however, before we get into that, I actually think we're going to go ahead and solve the partial product, and we're going to write down just the answer off to the side, which is very simple on this one, to the area model. Okay, raise your hand. What is the actual answer? Before we do the shading part, what is the actual answer, Lauren?
365.
365, like days in the year, right? 365, and then I'm going to circle that, okay? Same thing with this. Where is 365? Raise your hand. Where am I showing 365 in my area model? Where is that number? Let's see. The area of the rectangle, exactly. It's inside two numbers, but it's literally the area. So off to the side, I'm just going to rewrite that it's 365. Well now, I did those two steps first because now, in my standard algorithm, we're going to see why these all come together. This really is a shortcut compared to the other two, but we can talk about how they all relate, okay? In the standard algorithm, how would I work out that second step? Because I'm about to end up with my answer here without really even having to go through this many steps. Because what am I going to do next, Abby?
You would do 7 times 5 is 35, then you would add the 1 which gives you 36.
Exactly. The shortcut in the algorithm is just to think of this as 5 times 7 plus 1, which is 36. But who thinks they could talk me through that last step? She's completely correct. Who thinks they could talk me through that last step? Relating back to partial products, think about what the value of this 7 really is, and what the value of that 1 really is, and talk me through that last step the same way. Erin, what do you think?
So it's actually just 5 times 70.
Which is?
350.
Plus
10.
plus 10 more. She's exactly right. If I'm going to think of this as 70, what is this 1 actually worth?
10.
10. So 5 times 70, which is what we did here, gives you 350. Plus 10 more gives you 360. So when I put my 36 in the problem, is its value still 360?
Yeah.
Absolutely. Okay, great explanation, Erin. So now we're going to take our second color, which let's make that the green. We're only going to use the pink for the second example, okay? Because this one only had 2 steps. So with your green, shade in. You can go ahead and shade in the second step here. Okay, second step was 350. Our second step in the area model, I'm just going to shade over our outside length and width numbers. And our interior area, just on top of the number like this is good enough, guys. Okay, just to show the concept. And then in the standard algorithm, it's going to get kind of overlapping a lot because we use those digits in so many different steps. I'm going to shade over the 7 times 5, and I'm going to go over the 1. And I know coloring on top of crayon's a little tricky, guys, so just do the best you can. It's going to be a little green and a little yellow because we really used that number twice. We regrouped it in the first step. We added in its value in the second step. And then shade in the 36, okay? Because that was all involved in our second step. Yes?
I never realized that partial product is like a longer way.
It really is. It breaks it down. It's a longer version of this. But now that you understand the place value of all these numbers and you've applied it so many times, that's when now I can explain to you why this is a shortcut, but it still makes sense as far as place value goes. Yes?
When I do 2 by, it said it's just a 2 by 1. I've used 2 by 1 before. I use partial product for 2 by 2. I use standard algorithm before.
2 by 2?
Yeah.
Yeah, you can. We've practiced it a little bit. We haven't done it a whole lot yet. But you can do the standard algorithm for any kind of multiplication. You can. All right, second one, guys. 476 times 9. Jot that down on the lower half, please, of your paper. Hey, this is where we're going to need all 3 colors. Now, we're going to write it 3 ways. As before, 3 different strategies. This one, I'm going to give myself a little more space for those stack steps. Standard algorithm over here. I know I don't need quite as much room. And my area model has expanded. We've talked about this. These are not drawn to scale by any means. We're trying to keep them realistic, but it's a model, okay? And the term model in itself means that this isn't real. You know, it's a representation of what we're talking about, okay? So real quick to do the area model, who thinks they can come to the board and label the outside for us, the outside of the area model. All right, Erica, come on up. And you guys can go ahead and do it on your own. I know we know how to structure that. All right, awesome. She knows our larger portion of our length is 400 because she's breaking apart, decomposing 476, kind of like expanded form, into 400, 70, awesome. And finally, 6, okay? And then our 2 numbers on the end, those are the short sides, the width, if you will, would just be 9. Now, raise your hand, because this is tricky for a lot of people, okay? From the top of our model to our bottom is 9. We don't have a unit on it. We're not calling it inches or anything specifically right now, but it's represented 9 of subunits. These 2 dotted lines that I drew that are dividing up our model, raise your hand. How long are they? Raise your hand. How long are the dotted lines? Because you have enough information here to figure that out. And sometimes that helps people if we can label those 2 actually. How long do you think those are? Cameron?
9.
Exactly. If from here to here is 9, any line I draw within my model would be 9 in length. So actually, what I would suggest is jotting down a small 9 on top of your dotted lines as well.
Unless you couldn't have.
Right. True story. Yes.
I counted the dotted lines and there's 9 of them.
There's actually 9 little dashes. That's a coincidence, isn't it? Now we're going to do the 3 steps. I'm going to go a little faster since we've done this once before now, and we're getting the hang of it. Okay? First step. Raise your hand. What is the first step to all 3 of these? Ava?
6 times 9.
6 times 9, which is
54.
awesome. 54. With partial product, I'm going to stack my steps. With the algorithm, I'm going to regroup the what? Everyone? I'm going to regroup the 5. Put it exactly above the 7. Precision is so important here. That everything stays in the right place by position. Okay? And 54 can go on the inside of our area model. Let's stick with the same color order. We'll need the pink eventually, but let's go back to the yellow, please, and shade in all of your first step. Numbers that are involved in the first step in yellow. Again, I'm just going to color over the number itself and not shade in the entire section, just to save time. Okay? We're just connecting the 3 strategies. Okay? And using color to show someone who is just looking at this that we understand where every step is related in every strategy. Okay? Second step, everyone. Raise your hand. What would the second step in? And it kind of depends on which one I'm looking at. So let's start with the partial product. What is the second step that your brain, what are you saying in your brain right now if we're doing partial product, Truett?
9 times 70.
9 times 70. Is that the same thing that we're thinking down here?
No.
Yes.
Actually it is, right? Because this is 70, and these lengths that we labeled tell us that that's 9, okay? Now, Truett, what is 9 times 70?
630.
Perfect, 630. Okay, 630 and 630. Now, in our standard algorithm, what would the second step be? It's not going to give us exactly 630 because we had to regroup a number. Everything will come together at the end. Okay, but this specific step won't work out the same way as the first 2 because regrouping is involved. Donovan, what's the second step?
The second step is 9 times 7 plus 5, which is 63 plus 5. You group the 6 into the 100,
Correct.
and you get 8 as the answer for the 10.
Yes, you do. Perfect.
You have 84 right now.
And you put, exactly. So we have 84 as part of our answer so far. Which, can you see where 84 is going to happen over here?
Yes.
You see right now if I added up these two columns that I would get 84? That's not always going to happen. It depends on what we're going to have as our third step. But there is some hints of that over there, okay? Now take your green, that was our second color we used, okay? And let's shade over that second step real quick. So second step here, the 9 is going to get highlighted or colored in every time. We're using the 9 3 ways, 3 times. Okay, and then I'm going to shade over the 5, and I'm actually going to shade the 8 green and the 6 green. There was so much used in the algorithm on that step. I did this step, I added in the 5, which gave me the 68. Okay, so I know this is going to get a little funky with the algorithm as far as the shading goes. So just look up here. Shading matches all the steps so far. Okay, I'll give you just a second to catch up with that. And now this is when we are going to need our pink for our last step on this one, since this was a 3-step equation, obviously. Okay? Who can tell me what's partial product, what the third step would be? For partial product, which remember, we need to think of the values of the digits that we're working with. Emily? 9 times 400, which would be what?
3,600.
Awesome, 3,600. Okay, which also goes into our area model. Now our final step, again, before we go to our final step in our algorithm, I want to go ahead and find the answer to the partial product strategy so that I know when I finish this in a second, if my answers match, probably got it right. Okay, 2 different strategies tell me that. So who has, raise your hand, already added these 2 numbers up? I kind of ran out of space here, but I know you guys had room to do the regrouping. That looks like we needed on that last step there. What did you end up getting? Let's see, Sam? 4,284. Okay, exactly. Which would be the same answer we'd get if we added up our 3 area model sections. Now, clearly, what are we going to have right here? If it matches our partial product, what do you think we're going to get right here in our answer, Ben? It's going to be worth 4,200. Okay, I'm glad you're thinking that way. 4,200 is what we need to end up with here. Now with the algorithm, we're really just going to be thinking of it as 42 while we're working it out. But once it goes here, you're absolutely right. That's what it's going to be worth. Okay? So everybody, what is 9 times 4? 36. Plus 6 more would be 42, which obviously works out the same as our other 2 strategies did. Okay, final color would be pink, that you're going to use to highlight. And again, I know you're 9. You might not even be able to see the 9 very well anymore. Okay, because you have so much highlighting now going on. And my pink's pretty dark, but you can probably see on your paper how it's all working together. Okay, 3,600. Came from our 400 times 9, outside length and width on our area model is what helped us. So this is a great representation of how the 3 models all connect together. Oh, you're right, I should highlight this. Very good point. Okay, that's where our last step came from. So the entire purpose of this is now that whenever you have to work out an equation like this, if you wanted to double check yourself, clearly I think these 2 methods will be the fastest to use if you really wanted to double check. Okay, the area model, great representation if you ever need to draw out the model. Okay, now right now, go ahead and put your name on your paper if it's not there already, guys. And I'm going to collect these and hold on to them for you. We're going to put these in our